Okay, so the drug that I was assigned for this assignment was Abilify. Common brand names for this drug are Abilify Maintena, Rexulti, and Aristada. A generic name for this drug is aripiprazole, and then the chemical name I listed right here, and it's 7-4-4-2, 3-dichlorophenol-1 piperanylyl butoxy 3,4 dehydrocarbosterol. So common information about this drug: Abilify Maintena, or aripiprazole, is a prescription medicine given by injection for schizophrenia, adults with schizophrenia. It is a form of treatment of bipolar 1 disorder in adults. It is commonly known as a second-generation antipsychotic or an atypical antipsychotic. It rebalances dopamine and serotonin to improve an individual's thinking, mood, and behavior. Basically, it works in the brain to change how certain chemicals affect patients. It is stated that elderly patients with signs of dementia should not take Abilify due to an increased risk of death. Drugs such as clarithromycin, fluoxetine, paroxetine, nefazodone, fluconazole, ketoconazole, and trazodone are known to increase the levels and effects of aripiprazole. These side effects include euphoria, increased orgasmic activity, and pathological disorder, which can include compulsive gambling, shopping, binge eating, and sexual behavior. So now to the structure. I drew what the structure looks like typically, and then now I'll draw the line bond skeletal structure in lone pairs. So we have right here starting off, then we go to single bond. We draw carbons at every single end. So there, there. So this is a double bond right here. A single bond, double bond, single bond, double bond, single bond, and then it connects right here to chlorine. So gotta draw that. Then we have nitrogen, and then we have right here carbon, another nitrogen, and then carbon, and then another carbon, and these are all single pairs. So then it goes to another carbon right here, connecting to this nitrogen, carbon, and then we have oxygen, carbon. So then we have another structure right here. So we go carbon, carbon. Yeah. So then we have, I missed it right here, but there's supposed to be double bonds right there. So then we draw those in these lines. And then we have to finish off this one right here. So this connects right here to another carbon. Then there's a nitrogen, and then a double bond right here to the oxygen, and then there's some double bonds over here too. Just right here. So then we have all these, and the formula for this is, the molecular formula is C23H27Cl2 and 3O2. So we still have to add in the hydrogens because we know that in order to fill octet there has to be 8 electrons. So in order to do that, we add hydrogens places. So right here it has, carbon has 3 bonds, so we add one more hydrogen. This one has 3 bonds, so another hydrogen, and then this one has 2, so we add 2 hydrogens. This one has 2, so we add 2 hydrogens. This one has 2, so we add another 2 hydrogens. 2, and then these each have 2, so we would add each H, 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 and then carbon. So then we have to fill octet over here too. Hydrogens right here. It's kind of smushed, but yeah. So if you add all the hydrogens up, you get 27 hydrogens, and then adding all the carbons, there's 23, and then there's 3 nitrogens and then 2 oxygens. So that's the first structure, the expanded structural formula, and then we had to add our lone pairs in. So chlorine has nothing connected to it, so we would add 6 electrons right here. Another chlorine, so we'd add 6 right here, because as we know there's only 1 pair going here, so it still has those electrons left over. Nitrogen, it has going 3 ways, so that means it has 2 lone pairs left over, and then same thing right here, 2 pairs. And then oxygen, it has 6 valence electrons normally, and then it has 2 being shared, so then you add 4 lone pairs, and then same thing right here, 1, 2, 3, 4, and then nitrogen right here, 2. So yeah, if we make it a little bit neater, so I can show the Vesper molecular geometry. Oh, just fix it up a little bit. A little bit more neat structure so I could show each one of the molecular geometry and listing what kind of structure it is. So I'll start with the bent structures that are 109 degrees. So right here, that's oxygen. We have 2 lone pairs, and then we see that there it's connected to 2 atoms. So that'd be bent, and then that's the only one that's bent. So then going to tetrahedral, it would be this carbon right here. It has 4 going out. Same thing right here. And then right here. Each central atom has 4, it connecting itself to 4 different atoms. Same thing right here, same thing right here. Now going to trigonomal pyramidal, which means that they have lone pairs. So this one would be this nitrogen atom right here, as it has 2 lone pairs right there. Same thing with this nitrogen atom. And then same thing with this nitrogen atom. And then last one is the trigonal planar bond. So all these have bonds, and I'll make this orange. So this carbon right here, and then going all the way over here, and yeah, these ones each have 3 connecting bonds, and yeah, so that's the structure for